Hello, my name is Christopher George, and today I will go over how I created a full-stack application using containers, how I migrated that stack to AWS Serverless Cloud Computing, what some of the concepts behind serverless computing are, and how to secure a cloud application on AWS. I will be discussing topics related to containerization, orchestration, the serverless cloud, general development principles, and cloud security. To create my local application, I use containers to house the various components, that being the database, API, and front-end site. Containers were preferred over a virtual machine for this application for a couple of reasons. First, containers are a lot lighter on my machine since I only had to load the container engine rather than a full OS for each needed app. This cut down on the resource requirements for my machine and therefore helped speed up the development process. The second reason for the use of containers is the fact that, as Amazon describes in the white paper Container Migration Methodology, containerization has become one of the fastest developing IT fields that has received the most attention from the market in the past 2 years. And keeping up to date with new techniques is essential to ensure that business needs can be met in the most efficient way possible. The migration method most like the method used for this project was the rehost method. This model involves completely migrating all data to the cloud at once without any phasing over time. This was possible because the project itself was quite small when it was migrated, and it was not in active use. And so migrating the project was fairly simple and caused no disruptions. During the initial process of developing this application, Docker's Compose feature was very valuable to test the full application in a local environment. Docker Orchestration allowed the apps running in an individual container to talk to each other, and allowed each part of the application to be tested in a very similar environment to that it would be migrated to later. So what is a serverless application? Well, in the case of a full stack application, its architecture is just like a normal full stack application, consisting of a database, mid-level, and front end. Except that a serverless application doesn't run on a central server, and instead is made out of several services that are called on a per request basis. This means that serverless applications can be cheaper when the user load is low and can scale automatically when the load is high without the need to physically upgrade a central server. S3 is an AWS service that stores files such as front-end resources and images, but in this instance, it also hosts our front-end page. If we were to use local storage for this application, it may have been difficult to be able to make changes remotely or to expand the front end without upgrading the local resources. For this application, we are creating a form for questions and answers. As such, we need to implement a few basic functions. We need to scan the database for a record, get a record, get a question or answer, insert a question or answer, and delete a record. To accomplish this, we use API get, post, put, and delete calls to interact with the Lambda script, along with the ID and find one request to pass along the necessary data to Lambda and the database. The advantage of using a serverless system for the API is that all of the computations are done on demand in the cloud. For a local server, there may be significant lag time between a request being sent from a far distance and returning. With AWS, computations can be done on the nearest Amazon server to the user. To integrate the API with the backend database, an API call must first be created with a particular design. Say, a new feature should be added that edits a created record. In this case, a new API call should be created, say a put method, on the resource edit answer, also with an ID resource. With the API resource and method created, we should now create a Lambda function that can handle the call. The function would then search for the ID in the database, edit the given record, and return a successful 200 code or a failed code if a record is not found. For the database, Lambda scripts use queries to manipulate the key pair values in the DynamoDB database. In this case, the Lambda functions use the get, post, put, and delete queries to achieve their goals. The main difference between MongoDB and DynamoDB is that MongoDB uses the JSON file format, which allows for larger file storage. DynamoDB, on the hand, uses key pair values in the table that has support for JSON. This does limit the file size of DynamoDB files, with the benefit of better AWS integration. The serverless nature of AWS has several benefits when it comes to efficient resource utilization and easy scalability. As can be seen from the graphic, when demand is below the server capabilities, there is wasted money associated with the fixed cost to operate the server. Because there must be excess server capabilities in the event of a sudden increase in load, there is usually server waste. On the opposite end, if a server cannot be expanded fast enough, then the demand outstrips the server's capabilities and customers are left waiting for pages to load. Since AWS uses pay-for-use model, load capabilities are automatically scaled with an increased load and are scaled back with less load. This is a huge advantage when compared with a fixed server. In any application, security is a paramount concern. For something simple like limiting the access of a S3 bucket, permissions can be changed in the Permission tab of S3. In addition to securing a website, you will likely also want to prevent certain portions of your application from accessing other portions of the application. For this, AWS offers their IAM service. This application allows for the creation of roles and policies for portions of an application. Roles are given to sections of an application such as a Lambda function that assigns certain policies to that section. A role can have many policies, and likewise a policy can be applied to many roles. Policies are created with a JSON file uh, and can limit anything from a connection between a Lambda to a database to Lambda and an API to anything in between. In this instance, Lambda was prevented from accessing the database and the API. So a role was created to allow access between these portions of the application. Bear in mind, though, that the API did not have direct access to the database. In conclusion, AWS is a comprehensive full-stack solution that enables simple and resource-efficient scaling of applications. Serverless computations can help reduce lag time between the application and the client, and containerization is an increasingly popular way to create and deploy serverless applications. Thank you.